So now we're all set for testing. Let's see, first thing we'll check. I don't know which pin is supposed to be what voltage, so I'll have to figure that out. So let's start at pin 1. 4.96, and that's fluctuating. That might be a problem. I may drag my little oscilloscope out. Well, drag, it's a scope meter. So I might bring that out so we can look at the waveform. Let's see if that's common across the other voltages. Let's see, pin 2 is going to be DC. There's a capacitor on it, 3.2878. That should be 3.3. That's not too far off, but again, a little bit of fluctuation. Not a ton, but a little bit. Let's see, what's this one? Again, 4.97, and it's hopping up and down. And this one I would expect to be 12. Nope, 5. 4.9, still fluctuating. 3.27. Nothing. 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 13.46. Pretty steady, only a little bit of fluctuation. Yeah, I'm going to get the scope meter out, and let's see what that waveform looks like on those lower voltage ones. Alright, see here, it's an oldie but a goodie. So let's switch it back to scope. On auto range. Alright, let's see. Actually, let me switch hands. Alright, there's the 3.3. That's not bad. Put it back on auto. There we go. We'll check the 5. So I don't know if we're going to see the problem on the scope. Well, see, that should be a little bit flatter in my opinion. Just from what I've seen on the scope before, if I get a little more resolution, I think we'll see some ripple in there. So I'll just go to all the other ones too. This should be 13. Yeah, I think this is noisier than it should be. And just from past experience, I'm going to expect to find some bad caps. So let's get down there. Let's get in and get down to that power supply and physically check those capacitors. I'm going to unplug these wires now. The way I like to unplug these is I like to grab them up close to the connector, wiggle side to side a little bit, and pull straight back. I try to get on the plastic if I can, but sometimes you can't. You don't want to grab just one wire and yank. You could pull the whole thing out of the connector itself, like yank the wire out of the plug. Don't want that. Optoma is nice. They color code most of these. And then color wheel has a ZIF connector. Pull that out and that just drops right out. Ballast control. Then the power one I'll unplug once it's out. So let's see, those screws are out, those are unplugged. This should, yep. You grab it, grab the whole board. There's a big connector under there going to the DLP chip. So we'll pull that out. I'm going to have to do that. I'll just put the camera down. 1 sec. There we go. There we are. That's the main board. That connector there goes to the DLP chip. There's a ballast. There's the power supply. Let me get a bag, static bag for that main board. I don't want anything to happen to it. Now the next step is to take the ballast out. You got to take the whole carrier and ballast. I'm going to unplug the high voltage wire. That's 400 volts, or 385 technically. Now you could wait and not unplug the ballast from the main board and just unplug it here But I've had problems with those breaking sometimes, so I prefer to do it up at the main board. My preference, as always, your mileage may vary, yada yada yada. Alright, let me see. Yeah, those are too tight to do by hand. Alright. Ballast is out. That's the control board for the ballast. Those signal wires go through those opto-isolators, or two of the opto-isolators, to that control board. The third opto-isolator actually reports back to tell the projector if the lamp lit or not. There's some MOSFETs on that heatsink. It's a pretty light ballast, but they're pretty reliable. Rarely seen these fail unless somebody damaged it. Now take these 4 screws out, and then that ground screw, and the power supply will come right out. I forgot to mention, this model in particular has a bracket holding the power plug in. It's kind of a nice design. A lot of times these will get damaged from people wiggling the connector, the power plug, the wrong way. So don't forget to take out that screw, and that metal bar is going to lift off. And there we go, the power supply is out. None of these are obviously leaky, not on the top at least. Well, I can feel it. It doesn't feel like it's leaky. But I'm going to take these out and check them on the meter. So, be right back. Well, this is getting interesting now. All the capacitors check out. None are leaky. ESR is good. Microfarads are good. Going to put them back in, plug it all back in, and start checking another area. I need to make sure that the ballast is getting 385 volts, and then we'll also check the control lines to see if they're being driven when they're supposed to be. And there we go, capacitors are soldered back in, same order, etc. So I'm going to clean up that flux a little bit. I'm going to pop it back in, get everything set back in there so we can try it again and measure those other points I mentioned. And power supply is reinstalled, ballast is reinstalled. Turn the meter off. I'm going to put the main board back in now, plug all those wires back in, and then I'm going to set up a connection with the meter so we can check a couple other points. There we have all the other pieces plugged back in. Let's put that power cord in. The one thing I should have done, which I neglected to do, is check the 385. I should have checked that 385. But let's see, actually, let's see what that color wheel does. Take that screw out here, loosen that up. Take the shield off. Let's move that out of the way. Alright, we should see this spin when I power it up. Yep, so color wheel's spinning. That's good. And now the fan comes on. Interesting. Alright. So, next step then is to check the ballast control. We'll see if it's sending a signal to the ballast. All the other fans seem to be running. Blower fan, yeah. Interesting. There we go. We're trying it again. It's going to run 3 times before it shuts down. But I'm going to stop it. I'm going to check that 385. And I measured those 2 pins, and it's 385. So that's putting out the voltage. So that means it has to be a signal to the ballast itself, which would be kind of surprising. Or maybe the color wheel sensor. I'm going to plug that wire back in, and then we're going to see what the color wheel sensor is getting and what the ballast is doing.